Thanks, Giuseppe, for the introduction, and thank you all for being here to see this webinar. In this webinar, I will introduce the infrastructure manager. That's a component, as Giuseppe has commented, to deploy virtual infrastructures in order to ease the process of deploying virtual infrastructures on top of almost of the current cloud provider. So, as I'm saying, the IAM is a service in order to deploy virtual infrastructures on top of any kind of cloud resources. We use two different languages. First of all, we use our own language, the native language of the IAM, that is the RADL. But we also support TOSCA, that is an OASIS standard, in order to define the cloud topology. So the IAM has a paradigm of infrastructure as a code, as a single document can describe a full virtual infrastructure. And then the infrastructure manager is in charge of automating all the process, the deployment of the virtual machines, the configuration of the virtual machines, the installation of the software, also monitoring and update of the whole virtual infrastructure. It supports a wide variety of cloud backends, and this makes the user application cloud agnostic. This way you can have an RADL or a TOSCA document, and you can use the same one or almost the same one, make minor changes in order to deploy in different cloud providers. The IAM features DevOps capabilities. It is based on Ansible. It enables the user to describe the configuration of the virtual machines and all the infrastructure using this high level language. And it also provides a set of recipes for common deployment. So, for example, we are providing Ansible roles in order to deploy Slam clusters, Torque clusters, Mesos, Kubernetes, and any other tools that are currently used. The infrastructure manager works as a service that offers different interfaces. It has an XML, RPC, and REST APIs. It has a command line application, and it has two different web-based graphical user interfaces. I will show in the next slide. It is distributed using GPL license, and all the source code about all the IAM service and all the clients are available on GitHub. So the general view of the IAM is this one. It's a general platform to deploy on-demand customizable virtual computing infrastructure with the precise software configuration required. So a user can describe a set of virtual machines, and it can describe not only the software that must be installed in each one, but also the configuration in order to have all the components, all the virtual machines integrated in order to create a cluster. It allows to deploy any kind of complex infrastructure. It also enables, for example, the hybrid cases. For example, you can deploy a front end and a set of working nodes on your own on-premise cloud infrastructure. And then in some moments, you need some extra power, you can deploy extra virtual machines using, for example, a public cloud provider as Amazon or Oracle. It enables to share infrastructure descriptions. So I said the infrastructure descriptions are single documents, are text documents that are easy to share. It does not need to have prepackaged virtual machines in images, because it installs all the required software on runtime. So any existing virtual machine image can be used. And the same complex infrastructure can be deployed both on premise, for example, OpenNebula or OpenStack cloud providers, but also on public clouds as Amazon, Azure, or Google. As I said, it supports a wide range of cloud providers, and it also can be easily extended because it has a plugin design. For example, in case of public cloud providers, we are supporting Amazon Web Services, Google Cloud, Microsoft Azure, T-System OTC, and Express. In case of on-premise ones, we are supporting OpenNebula, OpenStack, CloudStack, VMware, and also LibVir. In case of federated infrastructures, we are supporting IaaS Cloud using both interfaces, the previous one OCCI and the current one OpenStack, and also Fogbow. But we are also support to create on top of container platforms, Docker or Kubernetes. So this is the working scheme. First, the users describe the infrastructure requirements using an RADL or TOSCA document. Then it is sent to the infrastructure manager that is in charge to deploy, contacting to the final cloud provider. As I said, we have two different languages. The RADL, that is the one that is the native one of the IAM that is designed by us, that is the Resource and Application Description language. That is a high-level language to define virtual infrastructures. And in case of TOSCA, we are supporting the YAML spec 1.0. That is an open standard to model application architecture. In the next slide, I will show some examples of how both languages how they work. In the case of RADL, it's like a declarative language, it's a text language. We have different keywords. There are Ansible, network, system, configure. They have different IDs and a set of features in order to describe each of the components. I will show an example that will be easy to understand. In this example, you can see we are describing in the first line, we are describing a network that we are requesting that has bound connectivity. So this is a public network. Then we are using the system keyword in order to describe a node that has one CPU and at least half gigabyte of RAM. And then we are defining a connection with the public network. And then we are defining a configuration of this node. We are using the YAML language of Ansible in order to create this task. And in this moment, we are adding a simple task that is the creation of a username usernode. And finally, we are using the deploy keyword in order to say that we want to deploy one node of the type that has been previously described. As you can see, with a single set of lines, you can describe a virtual machine. In the case of OASIS, this is in the TOSCA, it's an OASIS standard. This is defined to specify cloud topologies. It defines the interoperable description of services and applications to be hosted on cloud platforms. And using the standard has the advantage of enabling portability and to another platform. As here you can see how a simple TOSCA document how works. First, we have an import line when we can define a set of custom types, because TOSCA defines a set of, let's say, base normative types that you can extend, adding new types that can enhance the language in order to create new documents. Then we have the topology template. And in this part, we have an input section where we can define any kind of input that we want for our document. In this case, we have a parameter in order to describe the amount of memory of a virtual machine. And we have set a default value of 1 gigabyte. Then in the node template, we define a set of nodes that describes our infrastructure. For example, we have one node that is called Kepler, that is the type TOSCA node indigo Kepler. This node is defined in the custom type. Basically installs the Kepler software on top of the compute that this software is deployed. So you can see there is a requirement, there is a host section, and it says that this software is hosted on the Kepler server node. Then in the next section, we see the Kepler server node, that is the type TOSCA node indigo compute, that is, let's say, a virtual machine. Then we define a set of properties. For example, that we want a network that is the type of public, and that we need some port to be open, that is the BNC port. And then we define the properties of the node. For example, we said that we want with 1 CPU, and we are putting the memory size, then we are getting the value from the input section. And we are also setting the properties about the operating system. We are saying that we want a Linux Ubuntu distribution with version 18.4. And in TOSCA, we are also describing the outputs that we need. So in this case, we said that we want the instance IP, but in this case of the time from the Kepler server getting the first public address, and we are also getting the instance crest in order to enable to access the node. So in this case, we are getting the endpoint credentials that will enable us to access via SSH to the node. As you can see, in this case, the language of all the standards is a bit more complicated, but you can have a lot of features on it. In the infrastructure manager uses a urename convention in order to select the image to be used in the deployment of the virtual machine. For example, we use this kind of naming. For example, 1, 2 points / and the server, where OpenStack server and then the image ID. In case of OpenStack, we use OST and the name of the server and the image ID. In case of AWS, we specify the region and the MEID. We have also support for APPDB. In this case, we use this naming convention. We put the site name, the image name, and the BO we want to use. Then in the demo, I will show some examples. The IAM tries to obtain the list of IaaS providers from the credentials that are provided for the user. So in this way, the IAM does not store the credentials of the users, and the users have to provide these credentials in the code to the IAM API. So, this is how the contextualization process works. First, the IAM needs to connect via SSH to one of the virtual machines that is called master. This virtual machine is automatically selected by the IAM, and it must be a Linux-based virtual machine with a public IP. Then the IAM installs all the required software in the virtual machine, so basically install Ansible and configure it. And then this is this virtual machine that it is used in order to configure all the rest of the virtual machines of the infrastructure deployed. So there is an configuration agent that is deployed in the master virtual machine. And it is in charge of check SSH connection, call Ansible, and coordinate the contextualization step in parallel in all the virtual machines at the same time. About the client-side tools, the first one is the command line tool. This is a typical CLI tool. Have different parameters. For example, we can specify the API URL, and also you have all the operations that are enabled in different domains: create, destroy, get the information of the infrastructure, get the contextualization message, add or remove resources, and etc. Not all the operations are in this list because are quite long and does not fit in the slide. But there are also two different web interfaces that are open source. These are the links to access both of the interfaces. The first one is that we call the IAM dashboard. This is used for non-advanced users because it hides most of the complexity of the IAM, and with a single set of clicks, you can deploy on top of IaaS Cloud resources without any advanced knowledge. The second one, that is the IAM portal, it has all the functionality that the IAM provides, but as I said, it's a bit more complex as you have to define a set of parameters that in the other portal are assumed. And also, as I said, all the components of the IAM are available on GitHub. So, as I said, the web portal is a full feature web interface that is designed mainly for advanced users. It enables to define and share your own topologies. You can specify your TOSCA or your RADL language, and you can share this document with different groups of users. And it also enables to define the set of credentials with different cloud providers. You can access not only IaaS Cloud as the IAM does, you can access public cloud providers, OpenNebula, and any other cloud provider. And the web dashboard is for an advanced user, and it's an easy way to deploy a virtual infrastructure from a web browser. You cannot design your own RADL or TOSCA documents. You have to select it from a list of configurable list of templates. And in case that you have some special needs, you can contact us, and we can create for you this document and add to the list of available templates. The APIs that are available in the IAM, the first one is the XML RPC, and the second one, that is the most used, is the REST API. That it follows the Open API specification. You can see the full specification in the IAM documentation. The IAM, it is used in some components. For example, it is used in the VMOps dashboard of EGI. Currently is the OCCI communication layer to create VM topologies, but it will be moved to the OpenStack API. So these are the links that you have if you want to access this EGI tool. It is also used in other external projects, for example, the Data Cloud and the deep HDC project, where the IAM is a key component of the architecture. That is the component in charge of deploying the infrastructure and the orchestrating the deployment of infrastructures in different cloud providers, mainly in the public and in the OpenNebula side. Well, as Giuseppe has said, he will also show how the EC3 tool, that is another tool that uses the IAM behind, this uses the IAM in order to deploy the virtual elastic cluster. So now I will show a bit both web portals. Mainly, I will center in the IAM dashboard because it is the easiest one. But you can see also these two videos that were two demos in order to use both web interfaces to launch in top of IaaS Cloud. Okay, so maybe. Okay, so this is the landing page of the IAM dashboard. You have to log in using your EGI checking credentials. Now, as I have logged previously, probably I will directly enter. Okay, and it gets my information from the EGI checking system. First, you get this, that is the list of available templates that you have at this moment. As I said, if a user has a special requirement, we can also add a new one in order to enable the user to launch all the required infrastructure. In this case, as an example, I will create a Kubernetes cluster. Then you click on configure. And here you have a set of input parameters of the TOSCA document. Okay. In this case, it is separated into different tabs. In the first one, you have the hardware data, where you will specify the number of CPUs of the front end on the working node and the number of working nodes. Then you specify the Kubernetes data, for example, the Kubernetes version and the secret token in order to access the dashboard. In this case, you have the possibility to install the Kube apps application that enables to deploy graphically applications on top of your Kubernetes cluster using Helm charts. And finally, you have to select where you want to deploy. But let me say, I forgot one thing. First, you have to go to the service credentials. In this part, you have to specify one parameter that is required to the OpenStack authentication. That is the project that you are going to use. Usually, this project is linked to the BO that you are going to use. So you have two possibilities. One possibility is that you know previously because you have contact your site administration. Another possibility is that you only own one virtual machine in one site. And in this case, this step is not needed. But in case that you are part of more than one BO, this step is required in order to correctly access infrastructure. So, for example, we are going to access the site in CP3, for example. I have previously set this project ID, but if not, you have to access here, and you have this list of the BOs that you are part. You have to click here, and the ID of the project will be put here, and then you go to update. As we have done previously, we can go directly to the deployment of the infrastructure. So we click again in the case of Kubernetes. We put again the secret, and we select the site. So I will use the access DO. Then it will show the list of sites that are providing resources for this DO. I select the INTP3, and then we have two options. One option is to see the image in order to deploy, or in this second field, you can select directly the OpenStack images that are available. We have these two options because there are some sites that does not provide the AppDB images. So in this case, we have the two options. So in this case, I know that INTP3 is providing the images of AppDB, so we can select one of these virtual machines. If not, if this field is empty or you are having some problems, you can directly use this field in order to select the images directly provided from OpenStack. You can see here in this case are exactly the same that using the OpenStack name. And then you only have to click submit. Oh, sorry, I forgot to put that you have to put a name. I will put this one, and then you can submit. Then at this moment, infrastructure manager is contacting the OpenStack site at INTP3, and it starts creating all the required resources in order to deploy your application, in this case, your Kubernetes cluster. It creates all the needed resources, for example, create the virtual machines, but also create the required security groups and opening the required ports in order to enable you to access not only via SSH, but also to access the web interface of the Kubernetes cluster in a way that you have all the required software installed and configured and accessible for you. Let's wait a second. Okay. And here you have a list of the available infrastructure. In order to avoid waiting, because this configuration, the deploying of the virtual machine and the configuration of Kubernetes on top of the virtual machine will take some minutes, about 10 or 15 minutes, depending on the network performance and so on. I have previously then deployed another one. So in this list, you have a set of options. For example, here you can see the log. You can see the log, for example, the contextualization. In this case, you can see all the steps that are performed by Ansible to configure your system. And so you have here this configuration is below. So here you have this step of configuring the Kubernetes and so on. So here you have that all has been done successfully. Wait a bit, because it seems that the network is a bit slow now. Okay. But you have another options to get. For example, we are going to see the output. We'll open a new window. And these outputs, as I said, these are the outputs that are defined in the TOSCA document, where you define basically the output data that you think that is important for the user. In particular, for the case of the Kubernetes cluster, there are defined two endpoints. That is the endpoint of the dashboard of Kubernetes and the endpoint of the Kube app application. So for example, once the configuration is finished, you can click here, and then you have direct access to your Kubernetes, to your deployed Kubernetes cluster. Then you access to the token. You put, I don't remember. I have put in the previous step. Okay. And then you can see your access to dashboard and your Kubernetes cluster, and you can see anything you want to do with it. For example, we can see the list of nodes, but in this particular node, we are deploying only one node. But another ability that has the infrastructure manager, for example, is to elastically add new nodes. For example, in this case, we have two types of nodes, front-end and working nodes. And we are going to add new working nodes in order to add new nodes for the computing capacity of our Kubernetes cluster. In this way, if you have a previously deployed virtual cluster and you see that you need more working nodes for this Kubernetes cluster, it's an easy way to deploy a new set of nodes. And then the configuration step will reconfigure all the infrastructure in order to make this new node to be available in the whole system. As I say, I don't know why the network is going a bit slow, but at this moment, the interface contacting the IAM in order to add this node that will be added into the OpenStack site. Well, this is one of the problems of having this kind of webinar from home, that we are not having the same network connectivity that we were at our laboratory. Okay. In the meanwhile, I will try to show the other IAM interface. It is also integrated with check-in, but in this case, you have also the ability to register and access the web portal without having a user in check-in. You will see it is connected to the same infrastructure manager instance, so the list of infrastructure will be the same. And in this case, we have different sections. For example, we have this credentials section where the user can define the credentials in order to have a different set of cloud providers. For example, Open Nebula, OpenStack. Yes, you can see the same virtual infrastructure that we are showing in the other interface. Now, as you can see here, now we have the third node that we have added in the previous step. But also in this interface, we have the ability to have different cloud providers. For example, in this case, for Amazon EC2, but we can also add a different set of cloud providers. I will not enter into much detail. There are a video where this is shown, and there are also documentation. It's only to give you a overview of what you can do with that interface but it's not available in the previous one. And in this case, you also have the ability to create topologies. In the other interface, you have the ability to use this the topologies, but in this case, you can also define your own one. For example, here you have some examples. In this case, it's using RADL. As you can see, you can define a set of permissions in order to share this document among different groups of users. For example, this document has been created by a user that is sharing this document in all two lines that you cannot edit. And then that is you can the ability to create new one from scratch. In this case, if you have the knowledge to create a RADL or TOSCA document, you can create your own one. Okay, so as you can see here, we have the extra working node, and we have in the running step because it is configuring all the working nodes in order to get the new node to be configured. Here, you can click and get the information about each specific virtual machine. For example, in this case, I get the front-end information, and you can get the IPs. For example, this is the public one. You get the information of the feature of the node, and you can download the SSH key from the admin user. In this case, using this user and this key, you can access via SSH to the node. Okay. And here you have any other information, for example, the instance type and the ID in the OpenStack provider, the image that has the user, etc. All right. Finally, we have the first cluster that we have launched at EN2P3 that has been configured. And I think that you have almost all the information of the web interface. So I think that that's all that I wanted to show. So I only want to say that there are a set of video demos in YouTube. The IAM has an entry in the EOS marketplace. The IAM has a set of images in Docker Hub for the service, but also for the web interfaces. And all the source code is available on GitHub. And there is also a IAM info web page when you can see more information and all the documentation. So I have finished. So if you, Giuseppe, you think that we can start with the